Hello, in this part of the video we will be discussing fractions with exponents. We're going to look at what that means, and then we're also going to be talking about some more order of operations as well as something called complex fractions. It just means a fraction inside of a fraction. Alright, so an exponent, you know what that means, and it doesn't change its meaning with a fraction. We know that if we had 5 to the third power, that means you have 3 factors of 5. So 5 to the third power means that you would write 5 3 times and then multiply them. Now it does not mean 5 times 3. 5 times 3 would be 5 plus 5 plus 5. I said this is 3 factors of 5. Factors mean things that you're going to be multiplying. So when you have 2/3 to the fourth power, then that means down here, that means that you would write 2/3 4 times. So you can see we did that. We have it 1, 2, 3, 4 times, and then you're going to multiply. Now the nice thing that we've already discovered about fractions is that when you multiply fractions, you just multiply straight across the top and straight across the bottom. 2 times 2 times 2 times 2, that's 16. 3 times 3 times 3 times 3, that's 81. Now, if you reduce your fraction before you do the exponent, then there's no reducing on the end. That's because an exponent just makes you repeat the same factors over and over again. And if you've already decided that there are no common factors in this fraction, then there will be no common factors when you repeatedly write that fraction over and over. So no need to look and see if 16 and 81 will reduce. They do not. Okay, so down here we've got 2/5 to the third power. That just means 2/5 times 2/5 times 2/5. Or in other words, 2 times 2 times 2, that gets us 8. 5 times 5 times 5, that's 125, and then we're done. Hopefully you know that one. If you don't, if you put 5 times 5 together, you get 25. And now I like to think of this in terms of quarters. If I was counting quarters, I had 5 quarters, that's $1.25. So that's how you can do 25s really fast. Over here, I've got -3/4 squared. Well, the same holds true with what we did before with negative signs. It's not any different here. I do have 2 copies of -3/4, whenever, 2 factors of them that we're going to be multiplying. So we know negative times a negative is going to make a positive. And now I have 3 times 3 is 9. And 4 times 4 is 16. So I get positive 9/16. Now it's a little different down here with this next one, because notice I have 3 factors. I'm going to have 3 negative numbers. In other words, -4/5 times -4/5 times -4/5. I do that because this exponent here, it's like distributed to everything inside the parentheses, including that negative. It means I have 3 negative signs. And hopefully you'll recall that if you have 3 negative signs, that is an odd number of negatives comes out to be a positive, right? Because negative times it comes out to be a negative. Sorry, negative times a negative is a positive. Then we'll take a positive times a negative. That gets us a negative for the answer. Now 4 times 4 times 4, 4 cubed is 64, and we've already done the 5 cubed today, so that's 125. The last one here, -1/2 to the fourth power means -1/2 times -1/2 times -1/2 times -1/2. And so I've got 1, 2, 3, 4 negatives. That means it's going to be positive. If you have an even number of negatives being multiplied, you get positive. If you have an odd number of negatives multiplied, you get a negative. This is going to be a positive 1/16. Okay. All right, let's move on to order of operations with fractions. So what we have here is called GEMDAS, and notice how these are grouped together. The G does stand for grouping. Now, a lot of you probably have heard this with a different acronym called PEMDAS. And there's nothing wrong with either one of these. You just have to make sure that you're careful about it. PEMDAS, hopefully anybody that whenever you learn this, they talked about how these are grouped together. Addition and subtraction are the same level of importance. Multiplication, division, the same level of importance. First you do parentheses, then exponents. GEMDAS is the same idea. Sometimes people get a little confused if there's not parentheses. They think they don't have to do it, but you do need to group things appropriately. So grouping, make sure you group your numbers appropriately. Then we're going to do exponents, and then we're going to do multiplication, division. And this is not in specific order as far as multiplication division. What you do is you do them from left to right, how you find them in the problem. It's not like you go through and do all multiplication and then do all division. But this is something that you would have talked about already and is not going to be heavily focused on in this section. You probably want to go back and find something specific for PEMDAS or GEMDAS, like order of operations. Okay. So here's a few examples that are already worked out. You can see that what we did first here is we would do what's inside the parentheses. So you do the grouping or the parentheses first. There are no exponents. So 4/5 minus 1/5 is 3/5. Then you take that times 1/2. Right, so here's a couple nice examples for you to look through before we do one of our own. All right, let's go ahead and take a peek at this. First thing I'm going to do is any of the grouping or what's inside the parentheses. If there's an operation to do inside the parentheses, I got to do that first. And there is. Look at this. Here's a set of parentheses, and there's something to do inside the parentheses. I need to actually take 2/3 plus 4/5. So that's what I got to do first. So 2/3 plus 4/5. I've got to get common denominators because if I'm adding fractions, that's going to be a 15. So I'm going to take this one times 5 on bottom and top, and we'll take this one times 3 on bottom and top. That's going to get me 10/15 plus 12/15 will make 22/15. So that's the part that's inside this parentheses. What my problem looks like now would be 14/15 minus 1/2 squared times 22/15. Okay. The next thing I'm going to do, you might look at this and say, well, hey, I grew up with PEMDAS and I'm looking at parentheses, so I got to do parentheses. But the thing is, when we use that, there's nothing to do inside the parentheses. This is just a half. Nothing to do there. This is just 22/15. Nothing to do there. So we would move down to the next one. There's no more groupings. Now we do the exponents. So the next thing that we're going to do is this right here. Notice that the half is outside the parentheses, therefore it will not be included. So I've just got to do 1/2 to the second power. Well, that's 1/4. So I'll just put that right in here. Put that times 22/15 and 14/15 there. Now, let's see, we did a grouping. We don't have anything else to do inside the parentheses. We don't have any more exponents. Multiplication, division. There's a multiplication right here. So that means the next thing that I'll do is this part right here. So that's what I'm going to focus on next. All right. So if I do that, I can actually do some reducing. I know that 2 goes into each of these. That's weird. 2 goes into this 11 times. Why are you being like that, computer? And 2 goes into this 2 times. So now I've got 1 times 11 is 11. I've got 2 times 15 is 30. And now this is 14/15 minus 11/30. All right, we're finally down to it. We don't have any other operations to do. It's clear what we have to do next, and that is subtraction. So I've got to get common denominators. So that's just going to be 30. So we'll take this times 2 on bottom and top. This will be 28 thirtieths minus 11 thirtieths is 17 thirtieths. Okay, 17 thirtieths. That's it. That's our answer. All right. Okay, let's get on with it because we've got a lot of examples to work through today. This is going to get a little bit long, so as always, just skip ahead to what you need. We're going to do them right in order. Okay. So I've got 3/4 squared divided by the, so grouping or inside parentheses tells me I got to do this part first. The first thing that I'll do is make these into 24ths. Between 8 and 12, those would be 24ths. So let's see. I would take this one times 3, and I'll take the other one times 2. So that gets me 9 24ths minus 2 24ths is 7 24ths. So that's the first thing to do. The second thing to do would be this, my exponents. Right, I know I have a division sign here, but this one right here says 3/4 squared. So I got to do this part next, this 3/4 squared. And of course, 3 squared and 4 squared, that's going to make 9/16. So I get 9/16 divided by 7/24. And of course, whenever we divide fractions, we flip it and multiply. Or keep change flip is what some people think of. I just think you just flip and multiply. All right, so the next thing I'll do is 24 and 16. I know 8 goes into those 3 times and 2 times. And then we've got 27/14. All right. Down here, when you look at this, I know this looks like a fraction, but really this is just a division problem. That's all. It says 2 plus 1 divided by 15 minus 8. This is an instance where it's implied, this grouping thing that's going on. There's no parentheses, but it's still implied by having this division sign right here. You actually need to do the top and you need to do the bottom. So 6 minus, and then we've got 2 plus 1 is 3. 15 minus 8 is 7. Okay. Now when we go through our GEMDAS or PEMDAS, whichever one you want to think of, what we've got here is, let's see, subtraction or division next. Yes, division, that's what comes next. So this is 3/7 times the reciprocal or the refliprical. Right? You got to flip it over, flip and multiply. So we'll do some canceling. These cancel down pretty nice. Bam, bam, those are gone. And then 7 and 14 reduce down to 2 and 1. And now I've got 6 minus that. So 6 minus, let's see, all I have left on top is 2. And all I have left on bottom is 1. So this is like 2 over 1. But we don't usually write it that way. If you have a fraction, there's no need to put it over 1. This is just 6 minus 2. No more fractions. I know that's good news to a lot of people, right? Okay, let's keep at it. We've got negative 2/3 squared divided by all this here. So we've got, let's see, negative 2/3 divided. I'll probably do this first. That's our grouping part of it that we're expected to do. So 7 minus 2 is 5. 13 minus 4 is 9. Then the next thing that I'm going to do is the exponent here. So negative 2/3 squared remember, that's negative 2/3 times negative 2/3. That's going to be a positive 4/9. And we still have this minus 1/3 on the end. When you go through your PEMDAS or GYMDAS, we've got division before subtraction. So this is going to be 4/9 times 9/5. So we'll go ahead and get these 9s canceled out. I've now got 4/5 minus 1/3. And of course, fifths and thirds, those go together pretty nicely whenever we're talking about 15ths. We've got to get common denominators with these. So we'll do a 3 on bottom and top. And over here we'll do a 5 on bottom and top. So now I get 12/15 minus 5/15 is 7/15 for that one. All right, this is the last one of these before we move on to what are called complex fractions. Okay. So look inside your parentheses first. That one's easy to spot. When we have parentheses, your eyes should kind of go to them. We got to get common denominators, so we got to work inside the parentheses. So this is 7/8 minus 4/8 comes out to be 3/8. That's what inside the parentheses is. And I've got 1/16. And now one of the mistakes that some people will make is they'll square this and they actually just make this 6/16. Right? They multiply this times 2 and times 2 because they see the 16 here and they're like, well, I got to get to 16, so times 2, right? No, when you square something, it means that you're going to write another copy of that and you're going to multiply. It's a factor. Factors get multiplied. So I need 2 factors of 3/8. That will be 9/64. Now I've got to get common denominators. And with a little bit of practice, hopefully you'll know that 16 is related to 64. Right? It is related to it. Right? 16 is 4 squared. 64 is 4 cubed. And so this one needs another 4. It's missing a factor of 4. We'll just do that on bottom and top. And now I get 9/64 minus 4/64 makes 5/64 for our final answer to this problem. All right, the last thing we're going to cover today are called complex fractions. Now we're going to put these right in here with what we've been doing because there really is no difference. It's really just an order of operations problem. A complex fraction is a fraction that has fractions inside of it. So here's some examples of complex fractions. Notice we've got some fractions, a big division bar, and some more fractions. Now we know that division bar just means to divide. Like I know it's a fraction, but that's all a fraction means is to divide. So 3/4 divided by 7/8. And you could think of it kind of like this. 3/4 divided by 7/8 is 3/4 divided by 7/8. And of course 3/4 divided by 7/8 means the same thing as 3/4 times 8/7. Remember, you flip and multiply. And that's when you can do some reducing and then get your answer. So that's all we're doing here with complex fractions. So we've got, I think, 5 more examples for us to work through today, and then we're going to call it a day. 4 divided by 3 minus a half. Well, you always have to do tops and then bottoms separate. I should probably put those in a different color if I was going to do them separate. Right? Plus, there's nothing to do on top, so that's probably why I did it. So the top is going to stay the same, 4. Done. Done with the top. Now, if you want to, you can write that as a fraction. Maybe you're just like, hey, you said these are fractions and fractions. You could always write 4 as a fraction and just say, oh, that's 4/1. You know, I don't always do that, but you sure can. 3 minus a half, we got to get common denominators, so we'll do this. Now, you always want to have improper fractions. Oops. sorry. You always want to have improper fractions, not mixed numbers, whenever you're working with these complex fractions. So that'll give me 6 over 2 minus 1/2 is 5 over 2. So this blue part down here is 5/2. Now, what we've got is 4 over 1 divided by 5 over 2. If we've got 4 over 1 divided by 5 over 2, that's the same thing as 4 over 1 times the reciprocal, 2 over 5. I get 8/5 for our answer. That does not reduce. We're done. So there's one where we had to work on the bottom and get that all cleaned up. The next one, you should probably do it. Just do it on your own. Okay, pause it. I think you can. You've seen one example. That's enough because it's just an order of operations problem. All right, let's go ahead and do this. We got to do the top here together. So I'm going to take this times 3 on bottom over here, and I'll take this one times 2 on bottom. That's so that I can get the common denominator of sixths. So that's 4/6 plus 3/6 is 7/6. The bottom one doesn't need anything, right? I mean, you could do it and just put it over 1 if you want. So that's the top, right? That's just 7 over 1. So what I have here to clean it up just a little bit might look something like this. And now that we have it written like this, you know, to divide two numbers is to multiply by the reciprocal. So 7/6 times, and you flip the bottom one. Or, you know, maybe you want to write it out like this. Let's go ahead and take that extra second here to do that step, in case you're one of those people that uses keep, change, flip, right? I know a lot of people are taught that, so I want to reference that so you know that that's okay. 7/6 times, and then you're going to flip the second one. You multiply by its reciprocal. That's 1/7. So this becomes then, those are gone. We get 1/6. All right, we're down to our last couple examples that we have here together today. So let's make the best of them. Let's do the tops, and then we'll do the bottom. So we'll do that one first, and then we'll do this one, okay? So the top one here, we got to get common denominators with these, so I'm going to multiply this by 2 on top and bottom. That becomes -9/10 plus 6/10. -9 and +6 make -3. Right, you can just subtract the 6 and the 9, so you could think of it as like 9 minus 6 is 3. But the larger of these numbers is negative, so we got to keep that sign. Now for the bottom part, there's not a lot to do, but we do have to get this as an improper fraction, not a mixed number. So we're going to do 4 times 1 plus 1 over 4, right? Because we do the denominator times the whole number part, so 4 times 1 is 4, and then we do plus 1, that's going to make 5/4. So now I have -3/10 divided by 5/4, that will turn into -3/10 times 4/5. There's not a lot to reduce, but there is a little to reduce. And if you don't see it, then you don't have to right away. You can reduce at the end. But notice the 4 and the 10, those are both even. So I'm going to get a 2 out of there. Divide a factor of 2 out of each of them. So you take 4 and divide it by 2 to be 2. 10 divided by 2 is 5. And now we don't have any common factors anywhere. That just says -6/25. Okay, now we finally have some fractions on top that we've got to work with, and we have several fractions on bottom that we have to work with. Okay. So let's get to it. I got to get common denominators for the tops and the bottoms. There are some people, if you watch enough videos on complex fractions or you Google them, there's going to be some people actually that just say, well, let's find the LCD of 4, 5, and 3. And it actually comes out to be 60. And what they'll say is you can multiply the whole top times 60 and the whole bottom times 60. And this is a nice way of doing it. We're not going to really explore that in this video for simplicity's sake. But I just want to let you know that if you run across that, finding the LCD of the tops and the bottoms and multiplying, that's called clearing the fractions or clearing denominators. And so that's a great way of doing it. We're just not going to really explore it too much here. Instead, let's focus on getting just the yellow part put together. So I'm going to take these times, we'll take this times 4 over 4 on top and bottom. We'll take this one times 5 over 5. The reason we did that is to get our common denominator of 20. Right, that gets me 15 twentieths minus 12 twentieths is 3 twentieths. And then on bottom, we're going to multiply those. I got to get between 3 and 4, that's a 12. So we'll do this times 3 on bottom and top, and we'll do this one times 4 on bottom and top. Again, that's to get our common denominator of twelfths. So that's 8 twelfths plus 3 twelfths is 11 twelfths. And now when you look this over, we've got 3 twentieths divided by 11 twelfths. Don't forget, when we divide by a fraction, we're going to multiply by the reciprocal. So this becomes 3 twentieths times 12 elevenths. Okay, so 20 and 12, we can divide everything by 2. That will get us 6 and 10. Oh, look, we probably could have divided everything by 4 and been okay. So I'm going to just divide another 2 out, right? If I divide this one by 2, that makes 3. Divide this one by 2, that makes 5. Now I've got 3 times 3 is 9, and 5 times 11 is 55. So that's 9 55ths. Well, we made it. We made it to the last problem that we're going to do today. And I know that might be a little bit sad, but the good news is that if you really just miss me, you can go back and rewind this and watch it again. I don't mind doing this over and over again. I can do this as many times as you can click back. I'm good with that. All right, let's get going here. Again, we're going to separate these up into a top and a bottom. All right, so the first thing I'll do is I'm going to make this 4 over 1. And over here, I'm going to say this is 3 and 5/8. That's 24 plus 5 makes 29 eighths. Okay. Now I got to get common denominators, so this is pretty easy. I'll just take this times 8 and take this one times 8. So that will be 32 eighths minus 29 eighths is 3 eighths. Now this actually would have been pretty easy to do as mixed numbers, but we hadn't done any of those today, so I wanted to stick with consistency. But 4 minus 3 and 5/8, you could think of that as 3 and 8/8. Remember we talked before about borrowing. So 4 could become 3 and 8/8 minus 3 and 5/8. And now, of course, the 3's cancel, and you just have 8/8 minus 5/8 is 3/8. So maybe if you wanted to do it that way, I just wanted to show you real quick. Down here, this will be 6 plus 1 makes 7 halves. And this is 3/4. We got to get common denominators, so we'll multiply this by 2 over 2. And I get 14/4 minus 3/4 is 11/4. So 3/8 divided by 11/4. Now, that means that we're going to take 3/8 times 4/11. And yes, we can reduce. 1 and 2. And ultimately, we end up with 3 times 1 is 3, 2 times 11 is 22, and I get 3 20 seconds. Done. Woo, that's a lot of fraction work today. All right. Good luck with all of your complex fractions.